Good afternoon. This is Tria Case. Welcome to our webinar regarding the New York City outdoor lithium-ion storage permitting. We're happy to be talking with you, and I hope you've all had a chance to review the guide that was produced with FDNY and the Department of Buildings and City Planning. This has been an ongoing discussion with city agencies, and we're really here to work with you to clarify and streamline this process as much as possible, and to make that happen as quickly as possible. I'd like to start by introducing our speakers. On today's webinar, you'll be hearing from Jason Doling from NYSERDA, Bill Aker from New York Best, myself, Tria Case from CUNY, and Victoria Carey from DNVGL. You can proceed to the next slide. So I'd like to give you a little background on the program and what this team has been working on. We've been working hard with New York City to develop the permitting process, as you can see. On the whole, what we'll be doing is working with AHJs or municipalities across the state, and the goal is to develop permitting processes and associated guides to help develop best practices for you all, for energy storage vendors, and ultimately to provide the technical assistance that's required to both the industry and to AHJs across the state, so that we can really streamline the process and help to make sure that it is as understandable and that you can navigate it as quickly and as easily as possible. This program is led, this component of the program is led by Sustainable CUNY in partnership with DNVGL and Meister Consultants Group. And we have other technical assistance providers that we're able to work with as needed. So we encourage all of you, as you're going through the permitting process, to reach out to us, to let us know if you need assistance. And if you see a need for assistance at various AHJs, or if you are an AHJ on the line, please reach out to us. We're here to help you. I'd like to now introduce Jason Doling from NYSERDA, because really we are part of a much broader effort on the part of New York State to help reduce the soft costs of adopting storage. So Jason, I'll hand it over to you.
Thanks, Tria. So a couple of takeaways on this slide. First off, from NYSERDA's perspective, storage really is going to continue to be and increase its importance in really being a critical enabling technology that helps to facilitate achieving the state's energy and climate goals. And so that includes essentially doubling the amount of renewable energy that's contributing to our electric system needs to 50% by 2030, while reducing the carbon impact by 40% compared to 1990 levels. So what's really critical for that? That means we need to have large amounts of renewable energy that are available when needed, that can displace the need for otherwise less efficient older fossil plants during peak periods, and also provide additional resiliency and benefits to ratepayers and to customers. I mentioned all of that in way of highlighting shortly the Public Service Commission staff, DPS staff, and NYSERDA will be releasing an energy storage roadmap that identifies a wide range of policy, regulatory, programmatic actions that can be taken to help accelerate deployment and meet the governor's 1,500 megawatt storage target by 2025 on a path to a 2030 storage target that the Commission will establish later this year, along with the enforceable deployment metrics of how we're going to get there. And within all of those categories, soft costs play a pretty prominent role. So today, those costs, which can include permitting, customer acquisition, interconnection, high financing cost because of uncertainty driven by either performance or operational challenges, can all result in that installed project costing upwards of 20% or more. And those forces are really largely driven by New York State. So you'll see a large kind of underlying umbrella within that roadmap, which will be coming out again shortly for formal public comment over the next months, are really driven by factors that are unique to jurisdictions and within our control to help inform. And so for today's purposes, specifically related to permitting, there's a few things I just want to highlight in terms of where we are at and where we're headed to. And I know my fellow speakers will expand upon that. So first off, this work really began, I think, 3 years ago with Con Edison in what was affectionately coined the battery barbecue, to burn systems to help remove some of the just immense uncertainties surrounding what do we do if a system actually is involved in a fire, regardless of whether that began within the battery system itself or it was within a building that then engulfed a battery system adjacent to it. So that work was completed. There's a public report that's online. And then we recognized that really resource limitations were preventing the findings from that work to helping to inform the permitting process, specifically in New York City, as much as we would have liked. So in working with the two agencies, the fire department and the Department of Buildings, we made the commitment that we would bring on the resources needed to help transition those findings from the report and any other independent research and best practices into initially a set of model guidelines that would be followed by the agencies. These are their guidelines, followed by promulgating those as rules and then ultimately amending code. And Tria had mentioned working with other AHJs around the state. Last two things I'll just mention is the guidelines that have currently been developed with New York City go a long way to helping to bring clarity, but I am certain that there are many on the line who will identify places where that can further be improved. And I think both agencies agree with that it's a work in progress that will continue to become more and more effective. And then in terms of outside of New York City, we've been really clear from the beginning that we want to leverage that and accelerate the learning curve so that the multi-year process that was experienced in one of the largest urban environments in the country that has a huge amount of resources is not replicated elsewhere throughout the state. But also within there is recognizing that there are a number of requirements that are very specific to this dense urban environment. And so in parallel to the work that Tria will describe that's continuing with New York City is outreach coordinated through NYSERDA and the existing work that's been done with our PV network and other on-site power resources to really help develop what's a set of best practice guidelines that would apply everywhere. And then where are there really unique instances that would cause a higher level of requirement that might be appropriate for a very dense urban environment, but really may be unnecessary and not add any additional level of protection to further mitigate against the internal anti-cascading protections elsewhere. So look at what you're seeing today as being really applicable for the city, but not intended to be just transferable to any other location around the state. And then finally, I'll just reinforce what Tria mentioned, that NYSERDA, with support from the Public Service Commission, is in this for as long as it takes to bring immense clarity and reasonable and appropriate permitting requirements to not only build out the 1,500 megawatts that we are charged to building by 2025, but on a pathway towards what will be, I know, a larger and more significant target even in 2030.
Thank you, Jason. Yeah, and I'll reiterate, this is definitely a process, and I do want to encourage all of you. I see a few of you have already put some questions into the question box, but as we're we're moving along here. There's going to be a lot of dense slides, and if you have any questions as we continue, just put them right into that question box, and at the end we'll do our best to try to get to those questions. And if we can't get to them at the end, we will capture those questions, and we will post the answers on the DG Hub roundtable and get responses to you in any way we can. So with that, I'd like to also introduce Bill Aker from New York Best, and let him talk a little bit about the work that he and his team are working on to support this process as well.
Thanks, Treya. And if we could advance the slide. New York Best is leading the vendor outreach and education portion of the soft cost efforts with team members including CUNY, the DBGL, and Meister Consulting Group. And really the fundamental goal of the vendor education outreach is to advance the marketplace in New York State and to help companies get projects installed in the state of New York. So we are doing a number of activities to drive toward that goal. An important part of this is providing technical assistance to companies. And here I'm listing a number of areas that we're providing technical assistance for, and I'll talk a little bit about a few of those, but I also want to cast a wider umbrella here that as you're looking at doing projects in the state, if you're encountering any barriers, questions, anything where you need information, please reach out to us, and we can probably help or connect you with people that can help. In the areas of technical assistance, we do a lot of work helping companies understanding the tariffs, utility tariffs, the distribution network, and wholesale tariffs from the ISO. We do a lot of work helping companies understand utility programs and NYSERDA programs, including the ponds and the connection between the two, the non-wires alternatives programs of the utilities, various different demand response programs. There are a number of new programs that have recently come out. The Rider Q tariff in Con Ed territory is very interesting for energy storage. And very shortly, the VEDR Solar Plus Storage tariffs will be issued from the utilities on June 19th. We also do a lot of work working with companies looking at projects and understanding business cases and project business models. And then connecting people. If you're a solar company interested in energy storage and interested in connecting to an energy storage company or vice versa, or looking for inverter companies, project developers, engineering companies, the connecting and partner facilitation is an important part of our work. Understanding technology. If you're maybe a company that's interested in developing a project but may not be well versed in energy storage technologies, we can help provide some guidance on technology and product information. And as Jason mentioned, an important barrier for many companies is the interconnection process. The state recently added energy storage to the standard interconnection requirements. We will help you understand that and navigate it and work with utilities in the interconnection processes. In addition to technical assistance, direct assistance, we develop a lot of educational materials that can be found on both the New York Best Soft Cost Resources website that's shown below, and also on the NYSERDA Energy Storage Program site. I'll point you to two particularly that I think are quite relevant to take a look at as you're looking at projects in the state. The Energy Storage Services fact sheet outlines all of the different revenue streams that and services energy storage can perform and how they're presently compensated. So you can understand the various different revenue streams that you can access with energy storage in the different utility territories. And you can start to think about if you want to value stack and do things of that nature. And then the energy storage guide, and both of these documents can be found on the website shown here. Also looks at those various services, but takes it a step further in looking at how you can value stack and understanding how the different services can be performed together and what the limitations of performing them together may be. So a number of resources available to the industry that we'd encourage you to take a look at. And I really want to leave you with the message that as you're looking at projects in New York State or just generally trying to get information about New York State, please feel free to reach out to us, and we can access the rest of the team shown here to provide you with the information to make these projects move forward in the state. And with that, I'm going to turn things back over to Treya Case to continue.
Super, thank you, Bill. So we want to make sure that for those of you that have not had the opportunity to peruse the guide, that you know where to find it. You can jump on the NYS Solar map to Solar Plus Storage, and you'll see it there under the resources that are listed. We'll do our best to try to make sure that all of these resources that Bill's referring to and that others have referred to are accessible. But again, I'm sure this is good bedtime reading for all of you to read through the lithium-ion guide. And if you have questions or some suggestions, anything that you'd like to see, we refined in the guide, just let us know that and put your questions, into this questions box, and we'll do our best to respond to them. With that, I think what I'll do now is turn it over to Victoria, and Victoria is going to take us through. As I said, these are going to be some pretty dense slides to take you through the guide and through the standards that we've been working with FDNY and DOB to try to clarify. And as Jason noted, this is a process. This gets us part of the way there. We will end with some opportunities to think about how to further clarify and move towards indoor permitting. So with that, I'll turn it over to you, Victoria, and you can take us through the guide itself.
Sure. Thanks very much, Tria. So as you can see, we started this process a while back. There was a guide that was developed for energy storage systems that was related exclusively to lead-acid systems at the time. And there was a lot of concern and some consternation about moving goalposts and trying to get systems installed in the city, especially. So through a lot of dedicated meetings, we considered many areas of broad technical concern that we'll go through in a little bit more detail within this presentation, and that you'll also find outlined within the guidelines themselves. And through this process, developed consensus between FDNY and DOB, especially within the city. This consensus between AHJs allowing permits to move forward and installations to move forward in the city. Currently, those guidelines are exclusively related to outdoor and rooftop lithium-ion energy storage systems. And the idea where we're heading is first to eliminate areas of confusions regarding the outdoor guidelines. And then step two, as Tria was alluding to and Jason was also alluding to, is moving into indoor installations, moving to help expand these permitting guidelines to the rest of the state as is applicable or appropriate to the local needs, as well as considering other types of energy storage technologies beyond lithium-ion. So the Outdoor Lithium-Ion Guide, if you haven't seen it, looks like this. It's available as a PDF on the website that Tria had shown. This is the front page, and it was published about 2 months ago in April. And I just bring this up so that what we're talking through right now is really captured in the applicant checklist, which is included within those guides. So the organization is slightly different within this presentation because we're organizing it by topic area for clarity within the presentation. But if you can, pull up the checklist, you should be able to follow along literally as a checklist as you're going through trying to develop a permitting application and ensure that you have all the appropriate documentation for the size of system that you're looking to install. So I'm going to dive a little bit deeper into what these guidelines pertain to. So first, just a baseline, we termed small systems to be systems that were under 20 kWh. Medium systems were over 20 kWh but under 250, and large were exceeding 250 kWh. The idea here is to make sure that the things that might be appropriate to consider for a very, very large energy storage system may not be as applicable to small residential systems. This also follows size ranges that are included in up-and-coming standards and other standards that are coming out. So this process, as I mentioned, we gathered the stakeholders. So the the process in getting those stakeholders in the room, as well as the process to apply for a permit to install an energy storage system. It's a multi-organizational process. So you do have to work with New York City Department of Buildings, you have to work with the utility, and you have to work with the New York City Fire Department. So we considered, as I was saying, broad areas of technical concern. So we called these areas of discussion buckets, quote unquote. The way that we thought through these buckets was essentially you want to stop the problem, any issue before it could potentially occur. If it does occur, you want to limit its impact, and if it proceeds, you want to ensure that there's no danger to life or property. So the very first stage is lifecycle management. So this incorporates things like processes, quality management, installation, and operations and maintenance. So this is a very process-based step. So the idea is if it's well designed and well maintained, that you can have a safely operating system. The second area that we considered was status communications. Status communications include both normal operation status communications, so monitoring and maintaining the system, utilizing the BMS, as well as status communications in case of alarms and alerts. So making sure that you're controlling your system within safe ranges, and if the system goes outside of those safe ranges, that you can have automatic stops in place or notifications of faults. The third item was cascading protections. This sub-bucket is really going to be one of the ones that has a lot of standards associated with it. And it's to ensure, if things do proceed, that they are prevented from cascading. 4 and 5, around ventilation, exhaust, fire protection, suppression, and extinguishing, are all about mitigating, these catastrophic failures. So in case 1, 2, and 3 did not stop the issue from proceeding, the next item in the failure protections would be ensuring appropriate ventilation, exhaust, and fire protection. Finally, with 6 and 7, for siting and signage, the idea is that you site the system appropriately, so it's not putting any people or buildings or other items at risk, such as hazardous materials. And then signage will allow first responders or passersby to know what hazards may be in the area, as well as to have the contact information for a subject matter expert. So I'm now going to dive into the topics a little bit more specifically. Again, these topics are slightly differently organized than they are in the guide, but if you go through that checklist that I brought up originally, you should be able to find all of these requirements within there. So the first idea in lifecycle management is around the permits and inspections required. So this goes for electrical and construction, this is related to the Department of Buildings, and for operational, this is related to the fire department. Again, this sub-bucket is really related to processes. So with your application, you have to supply an installation, commissioning, and decommissioning plan. It's especially key to ensure that your decommissioning plan includes how to handle a system both at the end of its life, if it's a natural end of life, say a 10-year installation, or if it was only intended to be a 3-year demonstration or something, or in the case of an emergency. So having a subject matter expert available, specifically within 24 hours available on site if necessary, and available to be called at all hours. For maintenance, although FDNY and Department of Buildings are not looking to dictate how the system is maintained, as we understand all systems have a little bit of different standards. You do have to maintain records of the maintenance that's completed. You have to provide an O&M manual at request, and that if you do replacements, there won't be a requirement necessarily for re-permitting. If you are planning to increase capacity or change the battery type, that would require re-permitting and would not be considered replacement in kind. Replacement in kind would be something like swapping out a failed fuse, for instance, or an inverter of the exact same type. For status communications, the key features that need to be monitored are voltage, current, and temperature. That monitoring is required 24/7. It is required that there be an approved controller to balance those values. And again, Department of Buildings and FDNY is not in the business of dictating what the safe ranges of operation are for your system, but you need to know what those safe ranges are, and you need to provide them up front. If the system goes outside of those safe ranges, you must be capable of shutting down the system in case of that. So you have to identify detection thresholds and have alarms and notifications to activate at those thresholds or warnings. And then not just alarms and notifications, but also the ability to automatically stop. The system status should be displayed visibly on the unit. So this can be something as simple as a small LED indicator of various colors to indicate if it's in on or off, idle, fault, etc., or a small screen. This last item, if the offsite monitoring identifies issues deemed non-recoverable, the subject matter expert shall contact local fire department, is one of the areas where we're determining how it's best to proceed forward with that contact. But again, the key feature here is to know what the ranges of optimal operation are and safe operation are, and if it goes beyond those and is not recovered, i.e. if the temperature is rising and it does not stop rising, that the appropriate AHJ is contacted. For cascading protections, as I mentioned, this is where the standard heavy items are. So there are required testing and certification. So UL 1973, 1741, and 9540 have all been noted earlier. UL 9540A is a relatively new test protocol, and it is being looked for all systems being installed. As I had noted previously under the communication section, we do require that you can control within the appropriate and safe ranges, and that if that control is not available, there has to be an auto stop available. So it has to not only be available to you as the controller of the system, but also available on site in case an emergency stop on site is necessary. The ventilation and exhaust requirements under normal operations, and because this is specific to lithium ion and for outdoor systems, we understand that gases are not output by lithium ion systems under normal operating conditions. So ventilation is only required to support thermal management of the system. So that's per manufacturer specifications, and if the thermal management is handled in a different way, then it wouldn't necessarily be required. Under abnormal conditions, and depending on the outcome of the UL 9540A test data, an explosion analysis would have to be conducted, and this could include exhaust to maintain the LFL in the container below 25%. And then utilizing an engineering judgment, you can conduct the explosion analysis to ensure that if there were to be an explosion, that the explosion would occur upwards rather than outwards towards first responders. For fire protection, suppression, and extinguishing, there will be a requirement for sprinklers or sprayers over 250 kWh. And when UL 9548 test data becomes available, there may be an opportunity, depending on the outcome of those tests, to determine the flexibility within that requirement. Although non-water suppression is permitted, such as a NOVAC system, it's not allowed as the primary suppression agent unless testing demonstrates that it is as effective as water is. As such, water has to be accessible on site and meet standard pressure requirements. So that can be determined by a hydrology engineer. The cabinet and container requirements at the highest level, they need to be non-combustible and secure. Secure can indicate locked so that they can't be tampered with by unauthorized personnel. There are no limitations within a large container, say an ISO container, 20-foot container. You can arrange the racks within there as desired. However, the size might be restricted on those large-scale containers, just depending on what the local zoning determines is appropriate. There are not directly maximum allowable quantities per the container in site. Again, this is something where testing will come into play, as well as zoning. The requirements, as noted in the checklist, are limited by threshold sizes. So for instance, a 20 kWh system, if it were to be connected to another 20 kWh system for a full rating of 40 kWh, would be considered in the next threshold size, so the medium threshold size. If there is already an energy storage system on site, for instance, if two residents in a high-rise unit are both looking to install 20 kWh systems that are not planned to be interconnected, the FDNY and DOB must be notified that there is another system already on the property, but it does not bump it up into the next threshold size. For the fire protection suppression and extinguishing, and as is required in the 9540 standards regardless, an FMEA needs to be conducted. And in general, there needs to be compliance with all standing New York City codes, including New York City Electrical Code. We've noted here that NEC 2017 is recommended. Although NEC 2017 is not yet in force in New York City, it is the first of the NEC codes to directly address energy storage systems, and so it's recommended as a best practice. Sorry, having a trouble there, moving it ahead. So the guidelines relating to siting, again, as I previously noted, compliance is required with all standing New York City codes. So construction codes, that includes seismic, flood, weather, and vehicle impact protections. So there should be bollards around systems as necessary. If it's in a flood zone, there may be additional requirements. The container should be rated for outdoor installation, etc. The siting requirements, as you can see, this is siting page 1, and there is a siting page 2, and there's a number of separation distances from site features and structures that we go into in a lot of dense detail here. This is all included, again, in the checklist. Some of it is included as a footnote after the checklist, so please make sure you read through it in detail. But I'll go over it at a high level here. So there will be site-specific zoning requirements. So for instance, there may be a requirement to be X number of feet away from a path of egress or from a sidewalk. So this includes 10 feet from lot lines, public ways, buildings, stored combustible material, hazardous materials, etc. And in addition to that, there has to be separation from other energy storage systems on site in the case that the explosion analysis indicates that is required, or at least a minimum of 3 feet between containers over 250 kWh. Or you may install a line of protection, but it needs to be approved by the AHJ. And just as a note, since the explosion analysis is typically a requirement, if the line of protection is not supported by the explosion analysis, then it could be a non-starter. Or if the system is under 20 kWh, you may install it adjacent to a building. However, there are additional structural protection requirements relating to having a fire-rated wall behind the unit. And then there's the final caveat of, or if testing demonstrates otherwise and is not in conflict with the local zoning requirements. So if the 9540A testing that has been noted as required indicates that a closer spacing is permitted, then that will be considered. Specifically for rooftop installations, as I know there's a lot of interest in rooftop installations, especially in New York City where land is at a premium, they do require compliance with all of the standards previously noted. And in addition to that, there's a requirement to have a Class A roof assembly per New York City Building Code 15, or a non-combustible surface underneath, which would extend 3 feet beyond the footprint. If the unit is installed on dunnage, that dunnage must have a 1 to 2 fire rated coating on it. For installations that are on rooftops below 100 feet, they must comply with New York City Fire Code 504.4. That's related to access on the rooftop. Otherwise, the installations have to comply with zoning setbacks and height limits. For medium and large systems on rooftops, they must provide a standpipe connection at ground level for a dry sprinkler system or be interconnected with the building's sprinkler system automatically. In all cases, and as previously noted, there has to be an emergency stop on site, and that electrical disconnect should be accessible and it should be compliant with NEC 706 and ADA. And finally, for signage, I don't think any of these will be a big shock, but there are physical requirements for the signage, the size of the signs, the material that it's made of, and it must be replaced if it fades. The content does need to note that the space contains an energized battery system and identifies any chemistry-specific hazards. For instance, for a sodium-type battery to not apply water. The content requirements must provide subject matter contact information on the sign. The sign should be placed on the containers and at entrances to the area. They should identify the location of the emergency shutoff, if not within sight of the battery systems. And then there should be signage also by the emergency shutoff, identifying how it operates and what its purpose is. All other labels, again, as required in other codes outlined in New York City. So I'm just going to go through this really quickly, but we have 2 slides here, one for small systems and one for medium and large systems. As I mentioned earlier, this is really a multi-organizational process. So in all cases, both the utility, the Department of Buildings, and the fire department move forward in concert on installations. So starting in step 1, submission of documentation and approval moves forward. Then step 2 would be once approval to install is received, you can move forward to receive electrical and construction permits. And then finally, after installation occurs in step 3, there would be an inspection, and then that would lead to allowing interconnection as well as a fire department inspection to approve for operation. For medium and large systems, it's a very similar process. However, the idea is that we have scaled the permitting process to align with the project complexity. So whereas the small system had a more limited review by the fire department, in the larger systems, the fire department is involved all the way in step 1. And these applications should be submitted at the same time to the Department of Buildings and the Fire Department, and in coordination with Con Edison to determine interconnection requirements. Just as in the small system, however, this moves forward in the same way. So first, submission of the application, review, discussion, perhaps some iteration to ensure that you meet the standards, and then eventually approval. Step 2 then would be the construction and electrical permits. Step 3 would occur during or just after installation. And step 4, which is a new addition for the medium and large systems in comparison with the small systems, is that there would be a yearly inspection by FDNY to ensure continued compliance. You can see here, as I flip back and forth between the slides, the first one is for medium, and the second is for large systems. So there's a slightly more detailed requirement here for large systems, with an additional site inspection required in step 1. I'm just going to run through the forms real quick here that are required for submission, because I do see we're getting close to the end of the time, and I want to make sure we have time for questions. So for the fire department, they require submission of the TM1 along with all of the documentation noted in the checklist. This is a paper submission as a note, so this would be printed and mailed or delivered to the FDNY offices with a $420 fee required at submission. The OTCR2 is the Department of Buildings' first application piece of paperwork. This is submitted digitally. The format in which the documentation should be submitted digitally is included in one of the appendices of the permitting guidelines. This is required alongside a $600 fee at time of submission. This does require signatures of the applicant, professional engineer who's supporting the project, and owner. This is the OTC Project Checklist, which, as I noted, is included in the guide. This checklist will give you the order in which the documentation should be submitted digitally. So project info, which is listed as 1, would be section 1 of the submission. The next section, section 2, would be section 2 of the document submission, etc. The DOB PW1 form is the construction permit. So this would be step 2 within the process that I had shown earlier, the box flow diagram process that I had shown earlier. This is not required for the initial submission of documentation. I do want to note that links to all of these documents are included in the guidelines, so you should be able to find them easily from the guideline document. I am going to hand this now over to Paul Rogers, formerly of FDNY. He'll walk you through an example of a site that moved through this process and how it complied with the various requirements. Paul?
Thanks, Victoria. Okay, this is a Odyssey rendering of a energy storage system that was going to be put into a residential neighborhood. I just want to clear things up. As you can see, these containers are very close to each other, so this wouldn't work in a normal installation unless there was some sort of large-scale testing to prove that they could put them that close. So what I want to do is I want to show you here, this is kind of a busy slide here, but the New York City Fire Department really looked at this and they wanted to make sure that they could keep the responders safe in the event that there was an incident that took place. They really wanted to make this as a non-intervention. So as you can see, that CA here on the bottom here, right here, this CA stands for clean agent. When these things were originally designed, they had a clean agent that was already installed inside of them. The New York City Fire Department felt that they needed to have something beyond the clean agent, and they wanted to put water inside there. They felt that the clean agent wasn't capable of absorbing the heat from a battery fire, so they had the companies put in some sort of piping system, which is right here. So that piping system would be a straight pipe that would go into each one of these particular containers, and they would have a closed head system in there of a sprinkler system that would burn out at 212 degrees. The FDC here stands for the Fire Department Connection. As you can see, I have 2 in the picture. 1 would be at each side. So you would have 2 where the fire department could hook up their engine right to the Fire Department Connection and then start to put water in there in the event of a catastrophic failure. They also have an exhaust. In the event that there was a situation, there is an exhaust in each one of these containers. If the incident commander on the scene felt that he needed to exhaust the container for a potential flammable gas that may accumulate as a result of a thermal runaway event, he can override the exhaust system that's in there and start to exhaust any type of flammable gases that may be contained on the inside there. So that, along with a shutoff, and there would be a shutoff on each side here, that would be there for the fire department to shut off if there was an emergency and they needed to shut these things down. So there would also be some sort of signage here, and that signage would have that subject matter expert callback number or reach back number. So that would be in the event that there was some sort of situation here and the incident commander needed assistance, he would be able to call that number to get a subject matter expert or someone to the scene to have the handoff procedure. So because of the fact that we know that lithium ion has a tendency to reignite, the fire department really did not want to be staying there. If they felt that this thing was out, they want to make sure that they can hand off this this container to someone of authority who owns these batteries to make sure that they're going to watch these things until they start the decommissioning process, which would be getting these things out of the location as soon as practical. I'm trying to move to the next slide here. Can you? Thank you. Okay, so right now, this 9548 was mentioned before by Victoria. 9548 is a testing methodology, and the New York City Fire Department is looking to use the data that's generated from 9548. So what they'll do is they'll burn a single cell. They'll get some smoke composition off that, and then they'll start to build out from there. So they'll start off with a single cell, then they'll go into a module, and then they'll go into a rack level. And at that particular time, they'll be able to collect data. That data will help them to get information on the heat release rates, which would allow a professional engineer to design a suppression system according to the heat release rates of that particular system. It will also help to figure out the flammable electrolyte release rate, and they will help to design an exhaust system to remove that flammable gases that are generated during a thermal runaway event. It will remove it so we'll never get above the 25% of the LEL. It will also give some sort of heat release rates for separation distances. That's something that the fire department would like to look at. So this is a data-driven test trying to get information about that particular system, which will help the fire department to put in the proper suppression systems and other things that they feel are necessary for that. So the data that will be collected will be given raw data right back to the owner of the system. Then they will take that raw data, they will give it to a professional engineer who will design the features to keep that thing safe. So that information would go to the fire department, and then the fire department would look at the raw data and check it against the suppression system that the professional engineer had put in place in order to try to keep this thing from actually burning up. These are just some of the things that the New York City Fire Department is looking at, and you should be aware that 9540A is been looked at by some people, and they're looking to do some refining of 9540A because they seem to get a lot of questions from manufacturers. So 9540A will have another version coming out soon, and that would be something that you may want to take a look at when it does come out. From here, I'm going to give it off to Tria, where she'll take you to the next slide.
Thank you, Paul. So yeah, I mean, I think we've been hearing from many of you regarding 9540A, and we're interested to hear that there's another version coming out. It sounds like in the next week or so. But you know, we have been speaking with many of you about thoughts and input that you may have regarding 9540A, and I think it's important that we keep that conversation going. It seems, you know, UL is certainly open to hearing from all of us, so it's important that we, you know, gather our experience and knowledge and make sure that we're giving them the appropriate feedback so that the test is you know, as it needs to be, especially given that it will certainly guide, you know, much of where we see AHJs moving in terms of indoor guidelines, particularly in New York City. Toward that end, if you proceed to the next slide, one of the things that I wanted to make sure you're all aware of is that the New York Solar and Storage Summit is on June 19th. And one of the things that we'll be doing is holding distributed conversations throughout the afternoon. And we actually have one of the authors of the UL 9540A coming doing a specific breakout presentation and discussion around 9540A, and then having an opportunity for everybody to sit down and think about the opportunities and challenges that 9540A provides, so that we can really come together around any feedback we want to give to UL about that particular test. So I encourage all of you to think about the things that you would like to have input on and thoughts that you have around battery storage in general. And if you want to hear from one of the authors of 9540A, register for the summit, and we'll get you at one of those conversation tables, and we'll look forward to your input. And if you can't make it, if you proceed to the next slide, I want to make sure that everybody knows that you can certainly at any time reach out to dghub@cuny.edu. We can, route you to the appropriate technical assistance, whether it's through us or one of the partner organizations, and answer any of your questions along the way. So with that, I want to thank all of you for participating, and jump right into any of the questions that we can get to in the next 5 minutes. One question that came up was about whether or not we're recording this presentation and webinar, and yes, we are recording it, and we will post it up on the NY Solar Map website, and also provide it to NYSERDA and New York Best to put on their sites, and we will let you know when that is up. Again, if you're not on the DG Hub roundtable, email us at dghub@cuny.edu, and we'll get you on there. Also, I guess there are a couple of questions we should make sure we get to around sort of the small and the medium-sized systems. So Victoria, there was a question regarding sort of just telling folks again, what's the difference between the small and the medium-sized systems? And then also, if you could sort of from that move into clarifying what constitutes rooftop, and what the limitations might be around the rooftop applications.
Certainly. So just definitionally, the small systems are, and I'm having some trouble scrolling through the questions. So the small systems are under 20 kWh in size, and then the medium are 20 kWh to 250 kWh. The difference is, if you take a look in the checklists within the guide, and unfortunately, I don't know if I can pull it up here, back in the presentation. But if you take a look at the checklist in the guide, there are some items that are grayed out as not required for small systems, that are required for medium systems. As relating to rooftop systems, outdoor systems include systems that are installed on the ground level, as well as rooftop systems. So both types of systems are incorporated in this guide. For rooftop systems, they have to comply with all of the standard requirements as applicable and laid out for the systems that are installed at ground level, but because they're installed on a building, they're considered to be an additional risk. So in some cases where a medium-sized system might have less stringent requirements on the ground level, if placed at X number of feet away from various hazards, so 10 feet in the cases that we were talking about earlier, they might have less restrictions than a medium-sized system that's placed on a rooftop, where it is required that a sprinkler system be in place, a dry sprinkler system at least be in place for those systems, unless testing demonstrates otherwise.
Great. One other question that came up, Victoria, was regard to an FMEA template and whether or not there is an FME template available.
I can't name the standard right off the top of my head, but there is a standard format that will be required by FDNY and DOB, and it's noted in the guide. So there's a standard format noted in the guide.
Another question came up with regard to flow batteries and whether or not this guide applies, and any direction that we could provide with regard to flow batteries. Any thoughts on that?
I think it's safe to say that lithium ion is being viewed as both a prevalent as well as a potentially hazardous technology. And so if you read this guide, and utilize it as closely as possible for the flow batteries, I think that would be a good point of guidance. I know that 9540A, at least in the way that it's phrased, appears to be designed around lithium ion, but ensuring that you have data of what happens to your system under catastrophic conditions is important and would be useful to have on hand.
Can you speak to the one of the questions was with regard to UL, getting the full UL testing and whether or not you can proceed without that?
So the short answer is theoretically yes. You should design your system based on best data available and in compliance with the standards as noted. There is an allowance that's being discussed to allow for testing to occur for 9540A specifically at a later date. But the approval for installation would be given with the understanding that that testing would be completed at a later date. There are some discussions about the applicability, and as Tria and Paul Rogers both mentioned, some questions about how the UL standard can be applied and areas where clarity is needed. And as those areas of confusion are clarified and finalized, the standards and guidelines too will be finalized for New York. So there may be situations where some of the testing is not applicable, but right now the guidance is that all systems will need to be tested, but there will be a grace period.
Thank you. There are a couple of other questions which I think we can respond to and get out to all of you via the DG Hub Roundtable or even in response to all of you that registered for the conference. So we will make sure to do that and respond to, but I do want to be cognizant of folks' time since we've just hit 4 o'clock. Again, I want to encourage all of you to join the conversation at the New York Solar and Storage Summit on the 19th. And with that, I'll ask my fellow presenters if there's anything else that they would like to add before we sign off. Okay. Well, with that, I'd like to thank everybody for joining, and I look forward to seeing hopefully many of you at the New York Solar and Storage Summit on the 19th. Thank you.